Welcome to Math 2 Asynchronous Classwork for Day 29. Today, we're just going to walk through some factoring problems from CPM. I recommend that you try each problem first on your own, and then watch the rest of this problem in the video to see if you got the same answer, if you did it the same way, or if you have questions or you get stuck someplace, you can kind of see what to do next. All right. Our first question wants us to factor each quadratic expression below, if possible. We're going to use a diamond problem and area models for each one. So our first quadratic expression is x squared plus 6x plus 9. Well, the first thing I do is I grab my x squared term, my quadratic term, and I'm going to put it in the bottom left. There are a few ways you could set up the area model, but I recommend you do it this way each time so that you're following that same set of processes so that you can learn this really well. Factoring is like a door to so much more that comes up in math, so you want to make sure you have it down. If by the end of this worksheet and video you still have questions, go to your teacher's office hours, reach out to them, learn how to do this. You need this to move forward. All right, so that's our quadratic expression. We're going to put our quadratic term, our x squared, in the bottom left. And then the other term we can add to our area model right away is our constant, which is this 9. It doesn't have any x's attached to it. So we're going to put that in the top right corner. Now, I can't add anything else yet to my area model because I don't know how this 6x is going to get broken up. That's where the diamond problem comes in. So for the top of our diamond, we're going to take these two terms, our quadratic term and our constant term, and we're going to multiply them together. And we're going to place that in the top of our diamond. So up top here, we get 9x squared. So far, so good. Then we're going to take our b term. We're going to take our linear term, which is 6x. And we're going to put that in the bottom of our diamond. So now we have to think. We need numbers that multiply to 9x squared and add to 6x. If you're not sure where to start here, I highly recommend making a list and just starting with 1 and the number that you're going to multiply to. So for instance, I know that 1 times 9 gets us 9, but it does not add to 6. 1 and 9 don't add to 6. So then the next factor of 9 would be 3, and it would be 3 and 3. And if I add those together, lo and behold, I do actually get 6. So now I know that in both boxes here, I put a 3x. So again, that's because 3x times 3x is 9x squared, and 3x plus 3x is 6x. Then I take the quantities that are in the sides of my diamond, and I put those into my area model. That's how I know how to break up my linear term. So I'm going to put 3x here and 3x here. I'm not done. The last step here is the factoring part. First, I need to look for common terms in my rows and columns. I'm going to start with my first column here, just because. I'm just choosing to start with my first column. And I notice that this is x squared and this is 3x. So the greatest common factor I can take out of both of those terms is just an x. I don't mean to say just an x. X is very important. Okay. So now we can start building, and I'm actually going to start right over here because this area is x squared. So I need something that multiplies with this x to get x squared. So I actually just need another x. And if I look, that's also the greatest common factor for this row is just an x. Next, I'll look at my top row. So for these two terms, 3x and 9, the greatest common factor for both of those is 3. So I'm going to say a plus 3. It's a positive 3. And I can double check that because the area of this box should be its base times its height. So x times 3 is in fact 3x. So we're good there. Last but not least, I'm going to check out this column. What's my greatest common factor in this column? 3. 9 and 3x are both divisible by 3. And again, it's a positive 3. So I'm sort of done factoring. I just need to write it as factors. And I can write it two ways in this case. So I have x plus 3 times the quantity, x plus 3. That's one way that I can write the factorization of our original expression. Because x plus 3 is the same thing as x plus 3, we can also write it as the quantity x plus 3 squared. Because anything times itself, we can express as that term squared. And so in this case, we have this quantity times itself, so we can say that we have that quantity squared. So take a second. If you didn't do this on your own first, I would say pause this video, try the next one on your own, see if you can apply the same principles, and then check back in. All right, moving right along. I think we'll switch colors for this. So now we have 2x squared plus 5x plus 3. I'm going to start in the exact same place. I'm going to take my quadratic term, the 2x squared, and I'm going to place it in the bottom left. Then I'm going to take my constant term, the 3, and place it in the top right corner of my area model. Now, I can't go any further in my area model. I have to switch over to my diamond. In the top of my diamond, I'm going to multiply these quantities together and write that right here. So 3 times 2x squared is 6x squared. 3 times 2 is 6, and then we have the x squared. Then in the bottom of my diamond, I'm going to take my b term, my linear term, which is 5x in this case. So here's 5x. So now I'm looking for two terms that multiply to 6x squared and add to 5x. Well, if I had 6 and 1, right, 1 and 6, 1 times 6 is 6, but if I add those together, I'm not going to get 5, so that's out. So next, I'm going to try 2 and 3. 2 times 3 is 6, and 2 plus 3 is 5. So there I go. I'm going to write 2x here and 3x here. It doesn't matter. You could write them in the other order. You could put your 3x over here and the 2x over here. Either way. Then I'm going to take those quantities from the sides of my diamond, and I'm going to place them into my empty boxes on my area model. So I have 2x here and 3x here. Again, it doesn't matter which of the boxes you place them in. It will come out the same no matter what. Cool. Now we find the common factors in our rows and columns. So in this column, my greatest common factor is 2x. That's the biggest thing I can divide out of both of those terms and end up with a whole number. So I'm going to write 2x here. Then this time I'm going to go to the side. Why not? I'm just looking for my greatest common factors. My greatest common factor from those two terms, from 3 and 3x, is positive 3. I'm going to write that underneath. Next up, we'll address our rows. So the greatest common factor here, well, 2 and 3 are both prime numbers. I can't take anything out of those except 1. And then x squared and x, our greatest common factor is an x. Last but not least, up here, I can't take out any x's because this 3 doesn't have any x's. And again, 2 and 3 are prime. I can't divide out any other integer but 1. So that's the integer I have to use. I'm going to say plus 1. So last but not least, I'm done factoring, but now I have to write it in factored form. So my first term is going to be the quantity 2x plus 3, and I'm multiplying that by the quantity x plus 1. So just as a little reminder, what we were given is the area of this area model expressed as a sum. And now that we've factored it, we have the area of the area model expressed as a product of its dimensions. All right, let's try another one. And of course, we shall switch colors. Cool. We know the drill from here. We're going to take our quadratic term, which in this case is a single x squared, and we're going to write it here, x squared. Then we're going to take our constant term, which is the -7, and we're going to put that diagonal from our quadratic term. Now, I moved to my diamond problem, so I need something that multiplies to -7x squared and adds to my linear term, which in this case is 5x. Now this one's a little weird. I don't see anything right off the bat, so I'm going to make my list. So things that multiply to 7 are 1 and 7. And since this is a -7, I'm not sure which should be negative to get to a positive 5x. So if my 7 was negative and I added those together, -7 plus 1 is -6. That's not 5x, so it can't be that. But what if the 1 was negative? -1 plus 7 is +6, which is, again, not 5x. Well, usually next I would think about what other factors of 7 there are, but 7 is prime. 7 doesn't have any other factors. So this quadratic is not factorable. And again, we can tell that it's not factorable because when we go over to our diamond problem, we look and we see that there are no factors of -7 that will add together and give us +5. Well, that's kind of nice because now we're done. We can move on to our fourth factoring problem. All right, so here we have 3m squared plus m minus 14. Okay, getting fancy, but same process. We're going to take our quadratic term, put that in the bottom left corner, 3m squared. Then we're going to take our constant term, including its sign, and put that in our top right corner. So that is -14. Now, notice that this isn't using x as our variable, but that doesn't matter. Same rules apply no matter what variable we're using, no matter what letter we're using for the variable. So we're going to multiply 3 times -14 to put in the top of our diamond. So 3 times -14 is -42m squared, right? Because that m squared tags along with us. Then we know we're looking for those factors to add to +1m. So m. If it helps you to remember that you're looking for it to add to 1, you can also write 1m. Cool. So now we'll think about our factors of 42. And again, I'm going to just start with 1 and 42 just to be thorough. So I've got 1 and 42. Now, this is negative, so one of those has to be negative. If 1 was negative, they would add together to make 41. But that's not 1, so that's not what we're looking for. If 42 was negative, they would add together to be -41. Still not +1, still not what we're looking for, so it's not going to be 1 and 42. 42 is even, so it is divisible by 2, and that would be 2 and 21. So if 2 was negative, -2 and +21 would add to +19. That's not what we're looking for. And if the 21 was negative, then 2 and negative 21 would add to negative 19. Still, not the one we're looking for. So you can see that going through this process might take a little bit of time. As you work, you will start to get a spidey sense for what numbers you might be looking for. For instance, since this is 1 and this is negative, I know that my numbers have to be next to each other. I'm looking for factors of 42 that have a difference of 1. So that is going to be 6 and 7. So I'm going to write it in as 6m and 7m. Now, because this is negative, because we have negative 42m squared, one of those factors has to be negative. So if our 6 is negative, negative 6 plus 7 is in fact positive 1. So I'm going to add the negative sign to my 6. Now I have the sides of my diamond filled in. I can move them back to my area model. So I'm going to put the negative 6m up here and the positive 7m down there. Now, surprise, surprise, we look for the greatest common factor in our rows and our columns. I'm going to start with this column. So our greatest common factor in that column is going to be 3m. 3m. Then I'll just move to my next column, negative 14 and 7. The greatest common factor there is going to be 7. And it's a positive 7. So then if I look at my rows, well, 3 and 7 are both prime, so my coefficient on m is going to be 1. And then the greatest number of m's I can take out of those two terms in that row is just m, 1m. So that's our greatest common factor for the row. And then last but not least, my greatest common factor for negative 6 and 14 is going to be negative 2. Oops. Negative 2. Okay. Now, I want to double check before I move to writing it in factored form, and I'm just going to spot check it. So is positive 7 times negative 2 equal to negative 14? It is. So we're probably good. 3m times negative 2 is in fact 6m. 7 times m is 7m. And 3m times m is 3m squared. So all of our area pieces check out. So we're good. And now we can write our factored form. So again, it doesn't matter what order you write these in. Multiplication is commutative. They can switch orders. So I'm going to just say 3m plus 7 times the quantity m minus 2. And there we go. Now we've factored all of these using our area model and diamond problems. So take a pause, make sure that you could do this on your own. And again, if you're not sure or you have questions, check in with your teacher. All right, so let's move on to the next problem. Oops, there we go. So we've been working with quadratic expressions written in the form ax squared plus bx plus c. But what if a term is missing? Or what if the terms are in a different order? We're going to think about these questions while we factor the expressions below. So looking at A, our quadratic expression is 9x squared minus 4. So when I go to fill in my area model, I'm actually doing okay. So I'm going to draw these by hand because they're not all the same. We're going to pretend that's a rectangle and not a trapezoid. Okay, so we're going to make our area model as usual. And as usual, I'm going to put my quadratic term, so the term with x squared in the bottom left. So there's my 9x squared. And then I'm going to put my term that doesn't have any x's attached, my constant, in the top right corner. That's going to be negative 4. I can't do anything else with my area model, so now I have to move on to my diamond. I always have such a hard time drawing these by hand. That's why I made them for the previous problem. Okay, so when we are filling this in, we multiply this diagonal of our area model and put that in the top of the diamond. 9 times -4 is -36. So that's what's going to go here, -36x squared. But then usually I get my b term. I get what goes in the bottom of the diamond from the b term, right? The linear term that just has x to the first power. But I don't have that here. So in math, when it's not there, we say it's 0x. So we know that it adds to 0x. When we're looking for something that adds to 0, we have to find numbers that are opposites. So opposites would be like -2 and +2, -10 and +10. So we're looking for some number and its opposite that will multiply to -36x squared. So you may already be thinking this, but if something times itself essentially is 36, we have to think about the square root of 36. So we know that it's going to be 6 and 6. That's how we get to 36. And in order for them to cancel each other out, to add to 0x, one of them has to be negative. So now our terms that we're going to fill back into our area model are just opposites. We have -6x and +6x. -6x and +6x. Now it's business as usual. So 9x squared and -6x, the greatest common factor there is 3x. I'm going to write that below. Move to the right. This column, my greatest common factor is 2. 6 and 4 are both even, and that's pretty much all they have in common at that point. Next, we're going to look at our first row, so 9x squared and 6x. The greatest common factor between those two terms is 3x. Again, interesting. And then last but not least, in our top row, the greatest common factor between -6x and -4 is going to be -2. So when we go to write our factored form, you're going to notice that something kind of weird happened, something kind of fun. Our first quantity is 3x plus 2, and our next quantity is just 3x minus 2. So these are almost the same, but they're not actually the same. One has plus and one has minus. Think about maybe why that happens, and if that's always going to happen, right? If there's some sort of pattern that might be established there. But while you think about that, and chew on that for a minute, let's move on. So our next expression here is 12x squared minus 16x. Well, I don't know if I need to make a full-on area model here, but I will. Let's give it a shot. Okay, it's a marginally better box. Well, when I start filling this out, I know that my quadratic term goes in the bottom left. That's 12x squared. But then my constant term, we're not adding any constants, so it would be plus 0. So that's getting a little strange. If we then moved over to our diamond, right, we'd want it to multiply to 0x squared and add to -16x. I don't think it's going to work without that constant. I don't think we can use this type of box and diamond to factor this expression. So let's try something else. If you think back to Math 1, we actually did quite a bit of this with area models. So I'm going to write my two terms like this. So I'm going to have 12x squared and negative 16x. So I want to think about a greatest common factor here. I notice that they're both divisible by 4. 12 and 16 are both divisible by 4. And they both have an x, at least one x. So I'm going to take out a positive 4x. And then I have to think about what's left for each of those terms. So 4 times 3 is 12. And x times x is x squared. So now I can look, the length and width of this box are 4x and 3x. 4x times 3x does give us 12x squared, so we're good. Then I think about, okay, well, 4x would have to be multiplied by negative 4 to get negative 16x. Oops, that was supposed to drop. Right, so negative 4 times 4x is how we get to negative 16x. So then I'm just going to write my factors like I have for the previous problems. Since I have one factor that's a single term, I'm just going to write it as 4x times 3x minus 4. So there we go. Next up. So this is what the question was talking about. What if they're in a different order? Well, I recommend you just put them in the order we're used to, right? We're going to take our quadratic term first. So I'm just going to rewrite this as 8k squared. And then our linear term is this negative 10k. It's really important when you're rewriting that you pay attention to those negative signs. They are crucial. Negative 10k. And then last but not least, we have a constant of positive 3. So the 3 was first in the original expression, which is why there's not a plus sign in front of it, but it's a positive 3, so that's why we're adding it. Technically speaking, you don't have to rearrange it like this. You can go straight to your area model, but I think it will help to just have everything look the way we're used to. Okay, here we go. I'm going to get my diamond ready. All right. So first, bottom left, 8k squared. Boom, quadratic term, bottom left, always. Then constant term, upper right. That's a positive 3. We're going to multiply those together for the top of our diamond, which I'm going to make, oops, a little bigger. So 3 times 8k squared will give us 24k squared. Then our linear term, our b term, is negative 10k. So that's what goes in the bottom of our diamond. Now we're looking for factors of 24 that add to negative 10. Now, quick tip. When your product up at the top of your diamond is positive, there are 2 ways to multiply to a positive number. You can have a positive times a positive, or you can have a negative times a negative. So when the bottom of your diamond is negative and the top is positive, both of your factors have to be negative. So let's think about this. We've got 24 and 1. That's not going to add to negative 10 if we make those both negative. We've got 2 and 12. Also not going to add to 10 if we make those both negative. That would be negative 14. We've got 3 and 8. Ooh, those would add to negative 11 if they were both negative. So we're getting closer. So then we've got 4 and 6. All right, sweet. So negative 4 and negative 6 will add to negative 10. So the sides of our diamond, we're going to fill in with a negative 4k and a negative 6k. And again, this list is just something I like to make to organize my thoughts so I can keep track of what I've tested without losing track. Cool. So then we fill those in, so negative 4k and negative 6k, and we go about our normal rows and columns business. 8k and 4k have a greatest common factor of 4k. Boom. Move you over here. then negative 6k and 3 have a greatest common factor. We could say 3 or negative 3. But again, since this is negative and this is also negative, I think I'm going to take out a negative 3 because I need to be sure that when I multiply it by negative 3, or excuse me, I need to make sure that these can both be negative and this ends up positive. So then on my left for my bottom row, my greatest common factor is going to be 2k. And then last but not least, up top, negative 4k and 3 don't have a whole lot in common. So the only thing I can take out there is a negative 1. Now, I'm going to spot check this because I've got some negatives moving around, so I want to make sure. 4k times negative 1 is negative 4k. And then negative 3 times negative 1 is positive 3. I'm not going to check them all every time, but I feel pretty confident now that I've got my negatives in order. Everything's where it should be. I can write my factors now. So my first one I'm going to write as 4k minus 3, and that's being multiplied by the quantity 2k minus 1. And then that's it. That's our expression in factored form. So last but not least with this question, I see 40 minus 100m. Well, judging from the fact that there's no squared term, there's no quadratic term, I'm just going to jump straight to looking for the greatest common factor here. And, well, 40 and 100 are both divisible by 10, stand in 0. They're also both divisible by 20. So since I want to take the greatest common factor out, let's take out a 20 and see what happens. I'm going to draw a little side-by-side area model. I've got 40 and negative 100m. And if I take out a positive 20, to multiply that with something and get 40, I need to have a 2. And then over here, well, 20 times 5 is 100, but we've got a negative sign and we've got an m. So rather than just a 5, I'm going to say that it's negative 5m. Right? 20 times negative 5 would give us negative 100, and then the m tags along. So in factored form, I'm going to write my single term on the outside, 20. Oops, I'm in the way here. So I'm going to write my 20, and then I'm going to write 2 minus 5m. And that's as much as I can factor. 2 and 5 are both prime, so there's nothing else I can take out of those. All right. Last but not least, we're going to use this diamond problem and area model to factor this expression. And it's asking us a funny question. Is there more than one possible answer? Well, often when a textbook is asking you that question, the answer will be yes. So let's look at why. All right. You've seen me do this a few times at this point, so I'm gonna just go through it. So we've got 4x squared down here and negative 6 here. Then we know that this is going to be negative 24x squared, and this needs to add to negative 10x. We actually worked with something similar, but our signs were different, so we can't actually use that, which is annoying. I wish it was a repeat of a question we'd already seen. But we're going to think. So 1 and 24, those don't have a difference of 10, right? These are both negative now, so instead of adding to negative 10, they need to be 10 apart. Well, 2 and 12, oh, hey, those are 10 apart. So I know it's going to be 2x and 12x. And then since this is a negative 10, I need the negative number to have more weight. It needs to have a greater absolute value. So then my 12 has to be negative because negative 12 and 2 is what's going to add to a negative 10. Cool. So negative 12x and positive 2x, and then we factor. So greatest common factor for our first column is 3x. No, that's super wrong. 3 is not a factor of 4. Let's try that again. 4x, there we go. 12 divided by 4 is 3. Then we've got 2x and negative 6. Greatest common factor there, I'm going to say, is just 2. So then if we look at our row here, our bottom row, greatest common factor there is just going to be an x. And then up top, we're going to take out a -3 because we can take a -3 out of -12 and out of -6. And when I say out of, I mean divide by. So again, since we've got some negatives rolling around, I'm going to check my -6. 2 times -3 is in fact -6. Feeling pretty confident about that. So I can write my factors as x minus 3 times the quantity 4x plus 2. But I noticed that these are both even. So I could actually take out a 2 from that. And the way I would write that is I would take a 2 on the outside and then write the rest of my terms. The x minus 3 stays the same. But the 4x plus 2, we're going to divide each of those terms by 2. So I end up with 2x plus 1. It's really important that we look to factor our expressions completely, because the more factored we get, the more information we're going to have about what's happening as we start graphing these expressions. We're going to understand better what the graph looks like. So when you notice that there's still a common factor in one of your terms, take it out. Now, we could have actually done that at the beginning. If I get rid of all of these, just going to leave this, our final product, up in the corner here. What if, instead of waiting to the end to take out the 2, we take it out at the beginning? Because right away I notice all 3 of my original terms are even. So I could rewrite this expression as 2 times the quantity, 2x squared minus 5x minus 3. Then I can use my area model and diamond problem to factor just this quantity. So let's try it and see if we get the same thing. Quadratic term in the bottom left, constant in the upper right. Then we multiply those together to get the top of our diamond. That's -6x squared. We take our b term. Now our b term has become -5x. We take our term from the expression that we pulled the 2 out of. So this is -5x. And we're looking for values that multiply to -6 and add to -5. So let's try 1 and 6. So 1 times 6 is 6, and if the 1 is negative, then they would add to +5. But if the 6 is negative, then they will add to -5. So we're actually good to go. So I'm going to say -6x and +1x. Again, you don't have to write the 1, but you can if it helps. So I'm going to fill in my area model up here, -6x and 1x. And then rows and columns. Greatest common factor in our first column is 2x. Greatest common factor in our second column is just 1, right? 1x and -3 don't have a whole lot in common. So we have to pull something out. So we're going to take out a 1. Then in our bottom row, greatest common factor is x. And in our top row, the greatest common factor is -3. So when I look at those factors, I see I end up with 2x plus 1 times the quantity x minus 3. And just for the sake of matching, I'm going to actually swap that order. Again, they're being multiplied, so it doesn't matter what order we write them. But here's the thing that a lot of people forget. The original expression had a 2 in it that we factored out at the beginning. We still need that 2. It's still part of the expression. So we have to add it to our factored form out front, like that. But do we get the same thing? Let's take a look. 2 times the quantity x minus 3 times the quantity 2x plus 1. Yep, looks good. Same thing here. So hopefully that was helpful. Hopefully you're feeling more confident about your factoring. But if not, I bet you can guess what I'm going to say. Check in with your teacher. Put some work into learning how to do this. Until next time, I hope you have a good rest of your day.